With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello students, question is if A0 be the radius of first Bohr's orbit of hydrogen atom, the de-Broglie's wavelength of an electron revolving in the second Bohr's orbit will be. So in this question it is given if the radius of first Bohr's orbit of hydrogen atom is A0, then we have to find out the de-Broglie wavelength of an electron which is revolving in the second Bohr's orbit will be. Now, an electron when it revolves in an orbit, its angular momentum is quantized and is written as mvr. This is the angular momentum L, which is equals to integral multiple of h by 2 pi. So we will write this integral multiple as nh by 2 pi. This is the angular momentum. So if we write this for mvrn for nth orbit, so its radius will be rn. Now mv is the momentum. Momentum is mass into velocity. So we can write mv as momentum, that is p. So we will write p into rn is equals to nh by 2 pi. So we have to find it for the electron revolving in second Bohr's orbit for. So if we write for second Bohr's orbit, n will be 2. So we will write p and radius will be of the second orbit, so it will be 2. So it is 2h by 2 pi. 2 will get cancelled, so we will get h by pi. Now we will have the momentum as h upon pi r2. This is the momentum we will get. Now the de-Broglie wavelength is related to momentum as lambda is equals to h upon mv or h by p. This is the de-Broglie wavelengths. Now if we put the lambda is equal to h by p, p is h upon pi r2, so h by pi r2, so this will get cancelled and 1 upon pi r2, so this will go in numerator and become h is equals to pi r2. Now one thing more is given, if radius of first Bohr's orbit is A0. It means Rn is equals to 0.529 n square by z. This is the Bohr's orbit Rn. Now we can calculate here for hydrogen atom z is equals to 1 and for first orbit n is equals to 1. So Rn would be R1 would be 0.529 and this is given that the first Bohr radius is A0. It means 0.529 is equals to A0. Now if we write for second Bohr's orbit, it would be R2 into 0.529 into n square and n is 2. So that would be 0.529 into 2 square upon z is 1 for hydrogen atom. So that will be 4 into 0.529 and 0.529 is given A0. So that will be 4 A0. So this is R2. Now we have lambda is equals to pi R2. We have calculated earlier. So in terms of first Bohr's radius, that is A0, lambda will be, de-Broglie wavelength would be de-Broglie wavelength for second Bohr's orbit in terms of first Bohr orbit, radius of first Bohr's orbit, so that will be de-Broglie wavelength we have pi r2 and r2 is 4 A0. So we will get pi 4 A0 or we can write it as 4 A0 pi. So the de-Broglie wavelength we have calculated is 4 A0 pi. So now we will see the option which is correct. So the B option is correct. The de-Broglie wavelength of electron in second Bohr orbit will be 4a0 in terms of the radius of first Bohr orbit. So B option is the correct option. I hope you understood the solution. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.